is How to Instigate Action on Climate Change. Dr. Emanuel is Professor Emeritus of Atmospheric Science at MIT. He's the author or co-author of over 200 peer-reviewed scientific papers and 3 books, including Divine Wind, The History and Science of Hurricanes, published by Oxford University Press and aimed at a general audience. And he's also written What We Know About Climate Change, published by the MIT Press. Welcome, Dr. Emanuel.
Well, thank you, Molly and Julia. It's wonderful to be back here with you, and thank you for coming out on this cold, foggy night. Driving up from New Harbor was a kind of an adventure today. So the weather did try to cancel this, but they didn't succeed this time. So a lot of you probably follow the climate change debates and so forth. You're here, after all. Must feel a sense, as I do, frustration that there's not much actually happening globally about this. I'll show you some graphs. How do we change that? And I have some ideas that came from my years of being a climate scientist, but also my years serving on the boards of insurance and reinsurance companies and getting to know that industry. So some of what you might hear tonight, I think, will surprise you. Well, I hope it will surprise you. So the program is, first of all, I'm going to start off with a little science early while you're still awake. Try not to put you to sleep, but some of you probably know much of this already. And then talk about the human consequences of climate change, because 3 degrees of warming is not a human consequence. The consequences are what we feel in floods and heat waves and retreat from the coastline and so forth. And then I'm going to get to the main point, which is that we as a nation and actually as a global community have got to stop subsidizing risk. And I will tell you what I mean by that in a minute. I thought it would be nice for those of us from Maine whose eyes are tired of the gray of winter and the coming mud season to feast on this drawing. Yes, I'm supposed to talk louder. Okay, I will talk louder, and please tell me if I'm not speaking loud. My wife is always telling me to be quiet, so I spend a lot of time with your spouse in the winter. I think my volume has declined since October. Okay, this is a nice picture to look at. It's a very creative painting. It was actually done by an artist and a scientist. You may not believe this, but it's a painting of central Antarctica 100 million years ago. And Antarctica was not in a very different place on the globe back then. But it's an illustration of the fact that the planet does undergo climate change. I think you all know that. So West Antarctica in the mid-Cretaceous period. You may not want to be there for the same reason you may not like to live on the Amazon River, but that's kind of what it was like. And if you look at the history, this is the most technical graph by far I'm going to show you tonight, so don't worry about it. It's you see 2 time series, and the left-hand part of that chart doesn't go quite back to the mid-Cretaceous. It's about 65 or 70 million years ago. And at the right edge of the chart is where we're at today. So it's a chart that's 70 million years long. The upper chart is a kind of proxy for the surface temperature of the Earth, and there's a long and fascinating story about how we do that. It's all about geochemistry. I'm not going to tell you that tonight, there's no time, but basically you see the temperature scale at the left of that upper chart in degrees centigrade. And if you turn the clock back not 100 million years ago, but just 50 million years ago, you see that the temperature is pretty warm. 25 degrees. Today's global mean temperature is around 16 degrees, so a lot warmer. You also see that spike at about, about 60, a little bit like 55 million years ago. That's called the Paleocene-Eocene thermal maximum. There was a big spike, which is a fascinating story about how that happened and maybe a little bit analogous to our own time. But after that maximum in the Eocene, the temperature basically declined for a while, leveled off, and then started to decline again, and it's sort of at a low point now. Now, at the end of that sequence, you see a lot of noise. Those are the glacial cycles of about 100,000 years duration, which is a long time. but a tiny, tiny increment on a chart that's 70 million years long. All you see is a lot of fuzz. The bottom chart, which has a lot more scatter and noise because it's much tougher to do this, is an estimate of the carbon dioxide content of the atmosphere over time. And there's a lot of big error bars on that. It's a tougher thing to do, but you can say, generally speaking, along those lines, the temperature has followed the CO2 content. I don't mean followed as in afterwards in time, but the two are moving in parallel. And there's a lot of geochemical, geophysical evidence that over long periods of time, carbon dioxide has been a big regulator of the climate. So this is sort of one view of climate by looking at the history of carbon dioxide and temperature. Now, I want to just say, why is carbon dioxide important? And I'm going to give you a really fast tutorial on the greenhouse effect, which has nothing to do with greenhouses, but there we are. We're stuck with that term. What is it? So the first thing to do is to think about a planet just like ours, but it doesn't have any greenhouse gases in it. It has an atmosphere which is completely transparent to all forms of radiation, solar and terrestrial. On that planet, what happens is sunlight comes down. It's intercepted by the surface primarily. That would tend to heat up the surface, of course. A balance is achieved because all bodies, including all of us, constantly radiate. We radiate in the infrared, not in the visible. You can't see us at night. But the Earth also radiates in the infrared. And that radiation goes out to space, and there's a balance between the two. The radiation that goes out to space is proportional to the surface temperature. Actually, the surface temperature to the fourth power, but never mind. So as you heat the surface, you get more radiation at a particular temperature, you have a balance. That temperature without greenhouse gases globally would be about minus 18 degrees C. And if that were the case, we wouldn't be here to talk about it. There'd be no life on Earth, okay? Now, of course, the real world does have greenhouse gases. And what happens is they principally absorb in the infrared. They don't care about visible light. Visible light goes right through them. So what's happening at the surface is absorbing the same amount of sunlight, and it's radiating up in the infrared, but the gases in the atmosphere absorb that. Now, if that's all they were doing, they would just heat up over time. So what happens is they themselves emit radiation, and they emit it in all directions. So an equal amount up and down. So if you're at the surface of the Earth, you see that you're getting a certain amount of sunlight, the same as you were getting before, but you're also getting infrared radiation back from the atmosphere. Okay. And not only that, because it's infrared, you're getting it 24/7, not just when the sun shines, all right? Now the surface has to get hot enough to balance not just the sunlight, but this back radiation from the atmosphere, in the real world also from clouds in the atmosphere. And when you account for that, you get a mean surface temperature very close to what we observe, 15 degrees C, and we're all here to talk about it. Now, a little bit of history, because it's important. This greenhouse effect was discovered by an Irish physicist, John Tyndall, that grim-looking school teacher at the upper right. I think that's just the style of the times. And he built an apparatus, which if you're interested, you can see the actual apparatus in the British Museum. It's a long tube, and you can fill it. He could fill it with a gas of his choosing, oxygen, nitrogen, whatever. He would shine radiation of various different wavelengths through it and then measure at the other side how much of it got through versus being absorbed. He was the first person to do this. And he was able to quantify the gases. Now, if you were doing this experiment, you know enough about from high school physics and things, you know that the primary constituents of our atmosphere are oxygen and nitrogen. That's what he started with. And he didn't see any effect at all. So it became a very interesting story. This is a pie chart of the composition of our atmosphere. Nitrogen, 78%, oxygen, about 21%, argon, the green, 0.9%, and everything else is that tiny little orange slice that you might not be able to see very well, right? Well, Tyndall discovered that oxygen and nitrogen don't do anything. They don't absorb any of this infrared radiation. And later it was discovered that argon, the next most abundant gas, doesn't either. So all the greenhouse gases are in that little slice. Most of the greenhouse gases are water vapor, right? Which is highly variable, as you know, and carbon dioxide, which is approximately constant. Doesn't matter where you measure it unless you measure it near somebody's exhaust pipe, but it's globally otherwise pretty uniform. So it startled him. It says, well, the whole greenhouse effect of our planet that keeps us warm, no effect on radiation of the big constituents. That little orange slice makes the difference between a mean surface temperature of, in Fahrenheit, 0 Fahrenheit, where we wouldn't be here, and about 60, which is the present climate. And that's very deeply counterintuitive to people. Why? How is our climate regulated? But that is, in fact, the case. There's no dispute about that in science. That's really the case. It's worse than that because water vapor, the main gas, is controlled itself by temperature. If we blew up a giant water balloon and doubled the water vapor content, 2 weeks later, it would be back to normal because there's a balance between evaporation and precipitation and so forth. So it's that 0.04% that is our thermostat. And all the geophysical records, like I showed you, confirm that. Okay, now we're going to jump forward from Tyndall to Svante Arrhenius, who was a Swedish chemist, very gifted guy. He looks even sadder than John Tyndall. And I begin to wonder, is there something about climate scientists that, it's just a grim field? I don't think so. I think it's just the day. But he dabbled in lots of things, and he was very interested in the greenhouse effect. And he was the first person to worry that we were actually going to change it. So he published a bunch of papers, the most recent being in 1906. And he estimated with pencil and paper, obviously no computers, and not even the best physics in the world back then, that if you doubled carbon dioxide in the atmosphere, you raised the surface temperature by about 4 degrees. It's a pretty interesting prediction given that the current best estimates are somewhere between 2 and 4.5 degrees. So this isn't new. Somebody predicted it 120 years ago. He got a Nobel Prize, but not for that. For something he did in chemistry. You can ask, he was actually making a prediction. He thought we would alter the carbon dioxide content by burning greenhouse gases. Well, let's see how that prediction fared. So the red curve is the actual record of carbon dioxide going back to the late 19th century. It's actually the logarithm of it. Remember, he predicted, and it's correct, that the amount goes exponentially or logarithmically, with the carbon dioxide content. And then the blue curve is the measured annual mean surface temperature, global mean surface temperature. And yeah, it goes up and down. There are jigs and jags, there are volcanic eruptions. It's just pure chaos and weather. But by and large, yeah, I kind of got it right, okay? The message there is there's nothing new about this field. We've known about this for a long time. The difficult part of it is quantifying what's going to happen as a consequence of the temperature going up. And I want to turn to that in a minute. But first, if you look at ice cores in Greenland and Antarctica, you just measure the content, the gaseous content of the bubbles of air trapped in the cores. And this is a record of carbon dioxide going back 1,000 years. And in fact, you can go back 1,000,000 years, but I'm going to just show you the last 1,000. It went tooling along at about 280 parts per million. And then at the dawn of the Industrial Revolution, it soared upward and really fast. And that blue star is where we're at today, except it isn't because I didn't update this from last fall. That's how quickly it's increasing. All right. We're doing that, no question about it. We can measure the particular isotopic composition of the carbon dioxide. We know it came from burning fossil fuels. And it's a huge spike. We're well on the way to doubling CO2. Probably won't be able to avoid that. Okay, so now let's transition from a little tiny climate science 101 to why should we care about this? What difference does it make? And I want to illustrate that by another geophysical record, which is constructed from very clever geology, and that's the sea level relative to today's in meters, going back from today, which is on the right side of the chart, 24,000 years ago to the peak of the last glacial maximum, where it was 120 meters lower than it was today. You could practically walk, you probably could walk across Penobscot Bay if it hadn't been under a mile of ice, okay? There was no water there. And you can see the sea level rose at the end of the Ice Age, and it plateaued off around 7,000 years ago. It is not a coincidence that that's when civilization developed. As a species, we've been around for a long time, but we were nomadic. We settled down. We started to grow crops. We herded animals about 7,000 years ago. Most anthropological measures of civilization date back 7,000 years. And it's not a coincidence that that was the onset of an incredibly stable climate that we've enjoyed for 7,000 years. And civilization has become very finely adapted to this climate of the last 7,000 years. Okay, that's the message. If we change it, it doesn't matter what direction, whether it's up or down, it's going to be very disruptive. Now, to give you a little visual teaser on that, well, let me just say, 7,000 years ago, human civilization were very highly adapted to that. Now, here's a nice photograph of the New York City skyline. Okay, it's very pleasing. But if you look at that, it doesn't take a lot of imagination to see this is kind of an illustration of how beautifully we're adapted to this climate, right? A slight change in sea level would be very disruptive. Well, how disruptive? If we were to melt all of Antarctica and Greenland ice caps, that blue dashed line would be where the sea level is, okay? That would not be pretty. Now, that's not going to happen, okay? If it does happen, it will take a few thousand years at least. But, you know, even a few meters of sea level rise would be terrible, as we saw during Hurricane Sandy, right? Which, if it had occurred 100 years before it actually occurred, wouldn't have flooded most of downtown New York just because of the foot of sea level change. So that's one way to visualize it, but there's so many other ways one could talk about. Just to summarize from the IPCC, what are the known risks? Increasing sea level, we just talked about that. Increasing hydrological events. This is very simple physics. I wish I had time to explain it to you. But when you warm the climate, you get both heavier rain when it rains and less frequent rain. So you get more drought and you get more flooding in general. And we do absolutely see that in the data. That has serious consequences for agriculture, water supply, and so forth. Increasing incidence of high category storms like hurricanes, that's my own field, okay, and associated storm surges and fresh water flooding. We don't know so much about winter storms, which clobbered us here last year. More heat stress and other health risks. And if you pay attention to what the DoD has been telling us for 20 years, much more potential for armed conflict. Okay, so you're destabilizing civilizations. War historically is one bad consequence of that. There are benefits, some increase in plant productivity, just straightforwardly from the fact there's more carbon dioxide, but that gets a little complicated too, and reduction in health problems related to cold weather. But if you add it all up, okay, it is unfortunately very strongly on the negative side of the ledger. And the reason for that is that we're adapted to a climate that no longer exists. We're very, very finely tuned to that. Now, the Defense Department, you know, they're not a bunch of fruit juice drinking, sandal wearing hippies, came up with a pretty powerful statement, which if you read what they say, climate change is having very significant geopolitical impacts, contributing to poverty, degradation, weakening of fragile governments, and will contribute to food, water, and scarcity, increase the spread of disease, and may spur or exacerbate mass migration. Well, since they wrote that, it's become pretty clear that it already is doing that. Okay, so this becomes very serious, particularly in a world that's armed with nuclear weapons. All right, so not to belabor that point too much, despite a lot of publicity, people like me going around giving climate talks doesn't do a lot of good. Large subsidies for renewables, carbon emissions continue to go up. So this is just a record of carbon emissions. This is not the carbon dioxide concentration. This is the rate at which we're putting carbon into the atmosphere. It just keeps going up. Now, it has slowed down, but if we want to keep the temperature change below 2 degrees or so, we got to drop this curve to 0 by 2050. That seems very improbable to me, as much as we would like that to happen. So in spite of all of the talk and all of the meetings in Europe and so forth, not much is happening to emissions. I would predict they're going to go up for 2 reasons. One, that we actually, in a funny way, we don't want the emissions to go up, but hear me out on this. One is AI. AI is very energy hungry, and there may be some technical solutions that make it less so. The other is the growth of energy consumption by the developing world. There are 800 million people right now with 0 access to electricity. Does anybody want that? No. That's contributing as a major contributor to their poverty. Poverty, not just climate, it's poverty, right? If they get energy, and we want them to have energy, if it comes from fossil fuels, this curve is going to bend upward again. So the trick is, can we give them cheap energy that's not producing carbon emissions or take out carbon from the atmosphere? So now I want to get to the meat of the talk finally, which is why. Why aren't we making progress? Proselytizing hasn't worked. Okay, I tried it. A lot of my colleagues tried it. It's not working. So why are we failing at this? I'm going to make a pretty strong argument that because inadvertently we're subsidizing more carbon emissions. Let me try to tell you why that's so. We're inadvertently insulating people from the effects of climate change for humanitarian reasons, good, but short-sighted ones that's making things worse and worse in the long run while patching over the pain and suffering that we might otherwise be undergoing today. And we're doing that in a very unfair way. And this is where my interaction for 20 years with the insurance industry is becoming informative, all right? And we're even paying for people to move from less risky places to more risky places. This is a very well documented, but not very well publicized, mass migration all over the planet. But I'll focus on the US. Maybe I should focus on which button to push first. Okay. So along with that, here is something that's really quite startling. It's damages in the United States from natural disasters. These are the number of billion-dollar disasters going back to 1980 up to 2024. The colors are the particular weather phenomenon that caused the disaster each year. And you can see it's up, 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 right? And here is the same thing for the world. So all the sort of weather disasters tallied up and divided every year by the world domestic product. So we're taking out inflation and all of that. But it's still up 270% increase since 1970. Now you're probably sitting there thinking, wow, that's a lot of climate change. It's not primarily climate change. It's primarily demographics. The population of coastal regions, which are kind of a proxy for dangerous places, increased over this period by 200%. Okay, they went up, they tripled basically. And that there may be some, what we would call climate change, a threat multiplier. Okay, it's just it's exacerbating the amount of increasing damage just because people want to live in dangerous places. Why would they want to do that? Okay, I'm guilty of that too. All right, we're responding to incentives. Of those damages, an awful lot is due to flooding, okay? And we all have here in Camden, if you were around last year, you know what we're talking about. So why is this happening? Why are people doing this? Well, this is, first of all, a chart published in the New York Times, but based upon a lot of data that comes from professional organizations. This is kind of a loose tally of counties in the US that regularly get slammed by bad weather. That's the orange. I know it's not very contrasty. A lot of it's in the South, and some of it's in the Plain States and so forth. Here's another more precise tally from an organization I work with, just the number of climate hazards per county with moderate climate risk or greater. You can see we're sitting in one of those counties with a lot of risk. I'll come back to that in a minute. Okay, and so where are people moving? Well, this is another chart. The blue shows growth, basically, in population. There's a strong correlation between where people are moving and where it's dangerous. Why would people move from safe places to dangerous places? Well, of course, we all like, we're here, right? We're in Camden, we like the sea. Camden by the sea, I like the sea. I'd rather live next to it than elsewhere. Fine, okay. But there's a downside to that, is that we incur a lot more risk than people, say, living in Kansas. So the fact of the matter is that our nice coastal lifestyle is being subsidized massively by people living in less risky places. And this is the heart of the problem. Let me try to illustrate that. The first thing you have to do is understand that water, which is by far the most damaging thing, is not paid by your private insurance company. It's covered under the federal flood insurance program, and it has been since 1968. Very good reason why it was created back then, by the way. So if you're living in a floodplain, you are eligible, and if you have a mortgage, your bank will insist that you have federal flood insurance, all right? But political pressures force these rates to be low in risky places and too high in safe places. And I'm going to give you a concrete illustration of that. What's supposed to be a sort of need-blind organization, in fact, responds very much to people phoning them up and yelling at them, saying my rates are too high. All right, very much to that. Private insurance is regulated by individual states, usually through state-appointed insurance commissioners, but some of them are elected. And these regulations were put in place for a very, very good reason, to ensure solvency. It's exactly why we regulate banks. They can't just go under and take all your money, right? But when you need the insurance companies just can't say, well, we're going bankrupt, too bad, all right? We're not going to pay you. In fact, what's happening now is just the opposite. They're pushing the regulators are pushing insurance companies toward insolvency because they too have been captured by special interests. State insurance commissioners routinely cap insurance premiums in risky areas such as coastal regions, and I'll show you examples of that. So let's get back to the federal flood insurance. It's sort of the standard by which we measure things. It's used by banks to define mortgage risk. They usually will insist that you have a policy. The banks will. If you live in a floodplain, and I'll tell you what that is. It's used to set insurance rates with flood insurance maps. It's used to define building and land use regulations, used to build flood mitigation efforts, and used by homeowners and renters to understand their personal flood risk, not usually, but sometimes. Okay, here's an example I want to spend a little time on from New York City. So focus on those four maps in the center and look at the left one, it's 2007. This is a part of Brooklyn, New York, facing the ocean, which is to the southeast. It's called Canarsie. And in 2007, FEMA, who publishes the flood maps, denoted those blue areas as at risk of 100-year floods. Okay, if you lived in there, you had to get federal flood insurance. Then there was Sandy in 2012, the second map to the right. That's what actually happened. And that was probably more rare than a 100-year event, but not much more. And in the current climate, maybe just about a 100-year event. And it flooded a lot more area than that. So there are an awful lot of people who got flooded who couldn't even get insurance, okay, from the federal government. The third map was what FEMA proposed in response to Sandy. It's what you and I would do, right? At least make it look like, take into account the fact that we had Sandy, we have some evidence. Doesn't look exactly like Sandy, but there. And then after everybody howled and complained in New York City, they forced FEMA to scale it back to the map on the far right. This is what's going on all around the country. People are angry, coastal homeowners are phoning up their legislators saying, tell them not to charge me so much for insurance, all right? Okay. Now, if you think we're sitting pretty in Maine, get ready, okay? This is a different kind of map. This is all the counties in Maine. And the colors denote the ratio between the expected loss from weather disasters, like average over a long period of time, the expected annual loss, to federal flood insurance premiums. So where it's red, the federal government's going to pay out or has paid out lots more money than it's getting from the respective counties. And almost all of Maine is red, especially here. Knox County, it's the ratios between 200 and 500%. That's what a huge bargain flood insurance is for you guys. Now, I say you guys, I'm in Lincoln County and that's worse, okay? It's between 500 and 1,000%. It'd be crazy not to buy it on an individual level because it's being heavily subsidized. The federal government is going to lose its shirt in Maine, okay, from climate disasters. Somebody's going to pay for that. This is Florida, okay? Same thing, even worse. If you look at Palm Beach County, guess who lives there? Never mind. Between 1,000 and 2,000%, okay? We're paying, somebody is paying for all those people in Palm Beach County, all right? What's clear is that some of it's coming from inland, right? The blue counties are paying much more premium than they're getting back. Now, if you look at the whole, who's paying for it? Well, for example, Kansas. Kansas is all blue. The farmers in Kansas don't realize, but they will probably will, that they're paying much too much premium for flood insurance so that we in the coastal regions can not pay as much. This is the same map for the whole country. And you can see a pattern here, okay? The problem is that, we think of insurance as we should, at an individual level. What does it do for me? That's perfectly fine. But it could be a social good. It should be a social good in communicating risk to people, right? And telling them that if you want to live there, it's going to be very expensive, or you're going to have to build a very tough house or something to avoid a ridiculously high insurance premium, but we won't let that happen because of special interests, all right? We won't let it happen. As a consequence, in the net, federal flood insurance is deeply in debt, so it's bailed out by the national taxpayer, all of us. So this is just a history going back to 1980 of the premiums in blue, that's positive income for the federal flood insurance program, and the losses in orange. And you don't have to be much of a geometer to tell that the orange is winning that in fact, the whole program has lost $36 billion since its inception. Now, that number doesn't particularly worry me in the overall scheme of things. It's not such a big number, but we're stopping the signal of risk from getting to people. And the reason people aren't acting is because they don't feel the risk. So it's not just the feds, okay? This is, believe it or not, from a newspaper that was published here in Maine this morning. And this is an interesting thing because it's a great micro example of what I'm talking about. This is a meeting of the legislature, the state legislature's taxation committee that took place yesterday. And what they decided to do basically was to help businesses afford flood insurance. Sounds like a good thing to do. We don't want businesses to leave downtown. But who's paying for that? right? Who's paying for that? We can focus on the unfairness of people living in less risky places, subsidizing people who choose to do business in a floodplain. But that isn't really the big issue. The big issue is we're just encouraging people to keep building and keep operating in dangerous places. We're not letting insurance do its job, right? So these people, I'm sure, are very fine people doing a very good thing. But let's not make any mistake about that. It's not like they're malicious, but they aren't thinking, and they're not mandated to think in the long term. What are the long-term consequences of these bailouts? One after the other at the local level, at the federal level. We're constantly bailing people out. FEMA's flood maps are outdated. They're being challenged. They're based strictly on historical data collected over the last 100 years or so. So it's approximately 50 years out of date. It doesn't account for climate change. That's another problem. That's why the Sandy was such a surprise in New York. But that's beginning to change. There are nonprofits like First Street Foundation, on whose advisory board I sit, by the way, and others have started to get away from historical statistics and use actual physics, climate physics, to estimate risk. That's a long and interesting story, which I won't tell you tonight, but it is revolutionizing how we actually go about estimating risk. And these new estimates suggest that in many places, the risk is far worse than the FEMA estimates. There are a few places where it's the other way around, by the way. FEMA is overestimating the risk. So here is FEMA's current flood map for Camden. If you live in those blue shaded areas, you are in a floodplain and you are eligible for federal flood insurance. And again, if you have a mortgage, your bank will insist upon it. Fine. Now, this, I'm afraid I couldn't generate a map that's exactly at the same scale, but this is First Street's map. This is this foundation that does physics-based flood modeling. It's not quite the same quantity. It's a 500-year flood depth in feet. You can read it off the blue scale at the bottom. That red marker is where the Camden Yacht Club is. I'll come back to that in a minute. I always choose a public place to focus on, not somebody's house, because who knows, that person could be in the audience, right? It did happen to me once. And if you go back and forth, and it's going to be hard to do this, but for example, you don't see this area up above Chestnut Street that you see on this map. You don't see it on FEMA's map. There are a lot of differences, and if you tally it up, according to First Street, there are 124 properties with major or higher flood risk, and only 44 in FEMA's realization. So about a factor of 3. All right, so FEMA's getting it wrong. And this is contributing to the problem as well. Now there, it's not malice or even lack of intellectually paying attention. It's just old methods that don't work anymore. Old methods that were invented for a stable climate and have been made obsolete by the climate change itself. So I said I was going to look at the flood risk at the Camden Yacht Club. Well, the Camden Yacht Club floods pretty regularly, but so far it hasn't actually done all that much damage, right, to my knowledge. The flood factor from First Street rates it as the most extreme flood risk in their scale of 1 to 10. And if you look at, it's a little bit weird, the colors, but if you look at that bottom graph, it's the percentage increase or the cumulative risk of it's the cumulative risk of 3 feet of flooding reaching the yacht club building. And it's 0.7% this year, but over the next 30 years, it climbs to 46%. That's climate change. A lot of it's sea level rise. These are the sort of quantitative estimates people ought to be looking at now. This is the estimated change in insuring with the federal flood insurance company, the Camden Yacht Club. I'm not trying to pick on the yacht club. It's just that it's down close to sea level and it's public or semi-public. So I hope won't be offending anyone. But you can see it's soaring up in 4 times. And this is not inflation, okay? This is real numbers. If inflation is going to make it even worse than that, but 4 to 5 times in 30 years. We can also narrow things down here. I am going to pick on a private entity, but not not or just arbitrarily, is the Camden National Bank. The red dots you see are its branches all around Maine. And the black tracks are historical hurricanes. Okay, and so first we went about looking at the hurricane risk to the Camden National Bank. And they turned out, I mean, I didn't ask them to do this. In fact, they don't know I live up here. They decided to pick on Camden National Bank for a good reason. It's the #1 bank in the whole country in a particular metric. You ready for this? It's on the #1 in the top 10 list of US banks with the highest ratio of uninsured damage relative to the total property value of their portfolio branches. In other words, they're sitting on a lot of risk that's not insured compared to other banks. Okay, why is that? Just over 3.7 billion in outstanding real estate loans, and a 1% likelihood event, an event that would occur on average once in 100 years, the bank branches would incur 18 million in gross damages collectively, of which almost all of that is uninsured. So they'd be in deep trouble with that event. Okay, this is what I mean by people not being prepared for climate change, and that's right in our own backyard. Okay, and then this is just an example of what climate change is expected to do. This is Hurricane Florence's storm surge, which affected North Carolina, not here. With 1970 sea level, it actually flooded about 40,000 homes. 2018, it's up to 51,000, and by 2050, it's going to be up to 102,000. So that's just sea level. That's just sea level rising, increasing the probability of floods. So now we go to finally to the private insurance. Private insurance is regulated, and the purpose of regulation is so they don't fail when you need them, right? But they got captured, and they do something that's hardly done anywhere else in the US economy. The state tells them how much they can charge. All right, it's exactly the opposite of the free market, blah, 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 that people are used to in the country. You may not charge more than X. Well, that cap is in effect capping places in risky places. The places that are not in risky places don't come near that cap. So it's a subsidy for risky places. So here's an example. The state of California is the worst in this respect. They really clobber the insurance company. So this is the premium a company would have to charge to break even, basically, insurance premiums in California, back to 2010. So it's really only the last, 13 years or so. And all kinds of things have changed. There's inflation, and there's climate change in there. Cost to rebuild homes is going up. The orange is the light orange is the increasing risk from climate change. And the blue is indirectly that, because it's what they're paying to the reinsurance companies, which in turn insure them. So you can see it's gone way up, but that little brace you see on the far right-hand side is the difference between what it actually, a sound price would be for the premium and what California lets them charge. California says, no, you can't charge more than that. In no other business, to my knowledge, do we do that. But we do it here. And what happened? Massive exodus of private insurance from California. Massive. Allstate's the biggest insurance company in the United States. Farmers, State Farm, American National, Chubb, and Tokyo Marine all got out of California, leaving the California taxpayer in effect and ratepayer holding the bag. All right. And this is the name of fairness. And it is fair in a funny way in the short term, but it's horrible in the long run. It's just exacerbating, insulating people from risk. And then when the risk happens, as we saw in Los Angeles with the wildfires, it's terrible. Because since people aren't being encouraged to do something about their risks, they don't do something about the risk. Okay. And as a consequence, all across the US, private insurance has become very unprofitable. This is just showing profits in green, losses in orange, going back to 2014. It's the net combined ratio. For those of you who are in the industry, you know what that means. It's the ratio of your costs to your income. It doesn't add up, and so the insurance industry is in bad shape. The thing that's a shame is that it's a highly, highly competitive business. This is a list from the Maine state government's website. It's not even a complete list of all the homeowners insurance companies that do business here in Maine. That's not a short list. My company that I insure is not even on there. I look for it. It's a longer list than that. It's not like there isn't competition holding the rates down. And still we cap insurance premiums. Does it make a lot of sense? So what a mess is what I have to say. It really is a mess. And you might be thinking, well, okay, it's the insurance industry. What do I really care about this? The reason I'm telling you this is I think it's at the heart of the whole problem of climate change, is that we're messing this signal up in a serious, serious way. And if we weren't doing that, I think things would change much more rapidly than they are. So just to recap, national flood insurance has been captured by special interests in risky places, holding down premiums there with premiums too high in less risky areas. State regulation of the private industry caps premiums in risky places, causing insolvency in direct contradiction to their congressional mandate. They're supposed to do the opposite. They're forcing companies into bankruptcy when they're supposed to make them solvent. Okay? This is the power of special interests. We're paying for folks to move to develop risk-prone regions, driving up damages, with climate change acting as a big threat and multiplier of that increase. And the other consequences is we've inadvertently encouraged a massive migration. The migration isn't an accident. It's not just because people want to, but because they can afford to live in places that in some places they shouldn't be living at all. In other places, they should be paying to live there. They shouldn't be forcing other people to subsidize their choice to live in a dangerous place, but that's happening in a massive scale. On a fairness thing, relatively poor people living inland are paying the insurance bills of relatively wealthy people. Damages are soaring, amplified by climate change, and we're insulating mostly the wealthier and more politically influential people from it at their own behest. And so we are reducing their incentive to doing something about it. It's all about taking away a natural incentive to do something about climate change. We don't want to get hammered. Okay, so this is my last slide. This is more free-flowing from the hip. What do we do about this? It's informed, but your input to this would be very interesting to me. Okay, what are we going to do about the situation? To a first approximation, I have no idea. Not quite no idea. I have a few ideas. And the basic thing is we ought to stop subsidizing risk. It's just a foolish thing to do. We shouldn't do that. It's like paying people to smoke cigarettes. I mean, we wouldn't do that, would we? We don't outlaw cigarettes, but we insist that people pay more health insurance if they're smokers. It's fair, right? It also sends a signal to would-be smokers and existing smokers that maybe they shouldn't be doing this, right? So we should stop capping premiums, okay? And we should privatize flood insurance. Now, if we were to do that, it would be whole-scale mayhem and chaos, and it would cause immense suffering. In some places, the premiums would go up by more than a factor of 10. In some places, it go up by a factor of 20. Imagine getting your insurance bill. In fact, you have a 20-fold, not a 20%, 20-fold increase in premiums. So if you live in Palm Beach County, that's what would happen. In Knox County, it may not be a factor of 20, but it could be a factor of 10. Lincoln County is worse. So here I am arguing against my own interests. I have an insurance policy after all. You can't just do it. You just can't put those reforms in place. It would be awful. And that's where creativity, which I'm not in a position to argue for, it's not my world, but you should think about this. Government, I would argue, could ease this pain through a number of things. In extreme cases, buyback programs. It just offers to buy you out, basically, but insists that you, if they're going to buy you out, that you move to a safer place or build something that can take the expected weather. They could temporarily subsidize premiums for the less well-off, with the understanding that that subsidy would decline over time. So giving you kind of a buffer in which you can respond to the increase in risk. I don't know. I'm shooting from the hip, but I think it's important that we all think about this. We cannot go from the current disastrously dysfunctional insurance system to something more like the correct one. We can't do it overnight. It would cause way too much suffering, and that's the dilemma. And there's actually a big literature on this. A lot of the most dangerous places could undertake what's called managed retreat. That is, we're just going to get out of here, but we're going to do it gracefully and thoughtfully and reduce the pain of doing that. Whole communities, right? Not just individuals. I saw a picture once of a house that was built by a very wealthy person down on the beach in Texas to take a Cat 5. The Cat 5 came, this house stood, the rest of the neighborhood was gone. And the guy looked at it and says, what? No fire department, no police department, no neighbors, and left. It's about communities. It's not just about individual properties. I won't tell you the story, but I visited a tribal chieftain on the island of Fiji a few years ago and learned how he moved his whole town upslope after it was smashed by a typhoon. So those are my thoughts, and I'd be very interested in your reactions. Thank you.
It's very interesting because certainly where we live and where you live, well, where we live anyway, the increasingly it's the really wealthy who have the houses that are on the
Precipice, right?
right.
Figuratively, at least.
Yeah, well, yeah.
Yeah.
Who are now, does that, I mean, if you're looking at that and you say, well, could we just say above a certain property value or above a certain something? Maybe they do just have to accept it, or at least maybe a pretty rapid rise, so that in 3 to 5 years, say, it goes up to full value, full
That's
cost, actual real cost of the insurance.
So what the insurance regulators are forced to do now is to lift the caps up faster than they have. And that is disproportionately affecting the most expensive homes, but not entirely. So let's go back to the example of Palm Beach. All right, because I know that place a bit. A lot of wealthy, very high value homes on the coast, just inland, but just inland. There are literally slums, or there were when I was there, and very poor neighborhoods where people can barely afford their houses. And they're basically, a lot of them, their jobs are servicing that wealthy segment. They're the gardeners, the plumbers, the grocers. They can't take that cap increase, okay? Because it's per square foot, something, they can't do it. So if it were selective by wealth, you get into political problems. And the only way I can see my way around this, not by making that the premium a function of your personal wealth, all the other things being normalized by square foot, but subsidizing sufficiently poor ratepayers, at least for a while.
Yeah.
But I
raise it for everybody, but give assistance to.
Right.
Oh, I see.
Exactly. With the understanding that that assistance would decline over time, because you really want. But the thing that's so tragic is that when the big hurricane comes or the big flood comes, usually the people in those wealthier segments They listen to the reports, they have cars, they have friends, they get out. And the poor people are the ones who get killed. That's what happened massively in New Orleans with Katrina. That's the tragedy. And that tragedy is there indirectly because, again, we're subsidizing people to live in dangerous places. And it's complicated. I don't know what to say about it, but we have a big problem, that's for sure.
No, I mean, I hadn't thought about it particularly in flood insurance, but there's been a lot about it. And who pressures the regulators in Los Angeles and over fire insurance, which I assume works in fairly similar fashion. And
It does, believe me, yeah.
And the notion was that the subsidies were hugest in the richest property by far.
Yeah. Well, they turn out to be that,
And because
right?
they are the ones who call and shop the loans.
Right.
And hire the lawyers who shop the loans.
And the developers are another big lobby lobbying for lower insurance premiums.
Yeah.
And the thing is that it's weird because in the US, this shouldn't happen. I mean, it doesn't happen in other businesses that we tell businesses what to charge their customers, but we do in this business. And it's not because of lack of competition. You could say if it's a regulated monopoly, you have to regulate it. This is far, far, far from a monopoly. Yes.
So I'm trying to understand the consequences of the kind of fix that you're talking about, subsidizing poor people and making richer people pay more. And so I can imagine that one possible consequence is that now you have solvency in the insurance business. But I don't see people moving away from where they currently live, which is the long-term bigger problem, right? You want a disincentive.
You do.
For people to do this. So that's my first question. My second one is really, this was really fascinating and made me think about all the different ways that a certain kind of economic system like the one that we live in really insulates us from the natural consequences of what we're doing. There's so many other ways that this happens. We're subsidizing fossil fuel, we're subsidizing monoculture farms, we're subsidizing all kinds of things that are not in our long-term interests, right?
Yeah.
But it just strikes me that one of the things that all these subsidies do is that it prevents us from really getting the feedback and the information that we need about what's really happening to us. And so why should we change?
That's exactly
We're
right.
completely insulated.
Yeah.
By, we're being protected from the actual consequences of our behavior. And this is not just, in our economic system, but it really is an economy globally because other countries, developing countries, often pay the cost of our cheap, products. So we've been externalizing this for a while. So the whole system seems to be like this. And so how do you get out of that kind of system? You could fix maybe the insurance solvency, but it's a bigger problem, right?
You're absolutely right, it is. And the problem is that I think you put it beautifully, the short-term interests are exactly opposite of the long-term interests, and the short-term interests win. And that's why we're in this fix. On your first question, obviously if you just subsidize it, it wouldn't change anything. But if the subsidy was understood from the beginning to decline over time, we'll pay it next year, and the year after we'll pay a little less of it and so forth. It's kind of cushioning the idea is to cushion it, but that's just an idea, right? I mean, I'm sure people can come up with smarter things than that.
We call it ratcheting.
Ratcheting in a way. You're cushioning the blow of going from a really bad system to a more rational system. Yes.
Just sort of multi thing. I've spent a lot of time, although I grew up here, I spent a lot of time in central southwest Louisiana, Lake Charles area in particular, which people don't think about with flood danger because it's inland. But as we saw in several hurricanes a few years ago, it was as badly hit in some ways as Katrina did to New Orleans. And to your point of, and I've gone through, I've dealt with insurance and FEMA in those areas, and literally the house next door, because it's not on the FEMA map, doesn't get recognized. And we know also, talking to geologists and other people, that the current map of Louisiana is completely incorrect because basically at least a third of the state isn't there anymore. Maine is a very different thing because we have so much ledge in our coastline. We're not as impacted by erosion, but even in a place like Camden, when we're starting to do future planning around the shoreline, those maps. So what is the chance, or what is the process to get some of that? And we've seen a lot of, NOAA has done some projections of here's where, here's what 5 feet of sea level rise does, but we don't have a uniform, reliable system to get that data into government planning. Is there goods? What's the best source? What's the
Well,
best way to start getting there?
this is going to be a very biased answer. Go to First Street website. Anybody in this room can type up the address of a private residence into that and get a lot of information about risk, but not a commercial one. You have to pay them for that now. And I don't think they're doing, I don't know what the status of public property is. I got Camden Yacht Club because I'm affiliated with them, but you can type your own house address into that. I encourage you all to do that, and they
But
get
in
much more
terms of-
scientific reach.
In terms of qualifying
Yeah.
for insurance and communities trying to,
Yes,
if we're not all using the same best data,
Yeah.
how do we get everyone to agree what?
yeah. But I think the private insurance, if it gets this kind of good quantitative risk information, because it's competitive, if they're allowed to respond, they will. And that's what the free market ideally is supposed to do. But they need the information. The information has to come mostly nowadays from the scientific community, as opposed to the statistician, because working on 100-year-old statistics isn't going to tell us much about current risk. Yeah. Do we have anyone online, Julia, or I put them all to sleep?
They're all thinking.
That's a very nice.
So your place in New Harbor, are you actually in New Harbor?
Yes,
Because that got walloped.
it got walloped very badly. My
Was it
house,
March, that
yeah.
was the worst?
it was the January storms last year.
Because they had the one to follow on in March.
They did, but the two January storms where I filmed my neighbor's fish house being taken out to sea. It was horrible. I'm lucky, although not altogether luck. I remember asking the real estate agent 13 years ago or 11 years ago, how high is this property above? It's 80 feet above sea level. And so we don't have a flood problem, but a lot of the town does. They did get battered, several $1 million in damages.
Do you think we'll have to have a few more even worse events to kind of slap some sense into people?
I don't know. I don't think so. I think the problem again
The
is,
thing about it is
yeah.
it's apolitical.
It's weather is pretty apolitical, and it's true. Thank God there's something still. It's like- maybe that's too. And you had a question back there.
Yeah, I'm just sort of pondering something. I was wondering if this is a related effect. The rate at which coastal real estate is going up in value.
Yeah.
Might be that an investor could simply, accept all this and think, well, I'll make a profit in 3 or 4 years. So like, if it's turning over quickly, even with this whole mess, people can be making a lot of money. Versus the long-term homeowner, it seems like a very different scenario.
Yeah, it is a different scenario. And these are all things that really need to be deeply discussed. And people have to start off, I think it's partly my job, but a little piece of the job, with knowledge about what this true situation is today. And then let them come up with, I hope, creative solutions to that. Be great to see. And now
So are the people who are not in danger or supposedly, who's making them aware of this? I mean, you would if you were lecturing all over in the blue areas.
Nobody's invited me to lecture in Western
No,
Kansas.
So how does that message get?
I think some wit once said that all successful scams work by robbing lots of people of relatively small amounts of money to line the pockets of a few. That's what's going on. It's not designed to be a scam. It just turned out to be one, right? So there are lots and lots of people who are paying 10, 15, 20% too much premium to subsidize people who are paying, 50%, 20% of what they should.
No, if that information goes viral, people will get mad. How do you
They'll
make
vote
that
for
happen?
Donald Trump in Kansas.
I don't see any teenagers in the audience. Otherwise, we might have a leg into that. That's a good point.
I was just wondering if you have some written material that's digestible, basically what you shared with us, that we could actually, some of us is educating others to try to spread this information.
I don't. This is the very, very first time I've given this talk was tonight. I thought you would be the ideal test audience for it. And I am thinking about writing an essay. To be perfectly frank with you, I've been put off a little bit because we have such terrible problems to deal with at the moment. I feel I have to wait for the right moment, but it does need to be told in a way. There is a book that's sort of tangentially about this called The Geography of Risk by Gilbert Gull. That's Gaul, which I recommend to you. And it is about the subsidies of risk, basically.
Right.
Yeah.
If Trump got hold of it and said something, I mean, and the people who were paying higher insurance because of people on the coast, the dangerous places, it would travel.
I like to say that this is a natural place where free market ideologues and hippie coastal ecologists are natural bedfellows. Their interests are perfectly aligned because it would reduce the development and despoiling of the coastline if we did this.
Question on Zoom. As with automobiles, it should be mandatory to carry property and casualty insurance. What do you figure the percentage is of homeowners who do not have insurance in these fragile and dangerous areas are?
Well, that's a very interesting question to which I don't know the answer. I will say that if you have a mortgage, the bank will almost always insist that you have insurance, and you can forego insurance if you have complete ownership of the property, if you don't have any mortgage anymore. And I know that in Maine, there's a lot of uninsured property that's presumably been owned for a long time or something like that, but I don't know the numbers. Good question, though.
I feel like an infographic on just one piece of paper that could be easily shared.
Be good.
Great.
Are you volunteering? Seriously, I mean, I'm not a great graphic artist, but if you come up with an
Yeah.
idea for that,
I'll think about that.
yeah, absolutely.
Any other questions? Are you planning to do this again in other communities, like Rockport or Bowsburg?
Not specifically, but I'm happy to do more talks along these lines if you think it would be useful. Yeah. Okay.
And we often put the slides, if you'll let us, you'll have to work that out with Julia. Sometimes the slides, the deck actually goes on the website with the
Sure.
YouTube video. which-
I've been pretty careful to put sources of information on the slides.
Yeah.
But if you encounter one that doesn't, you should let me know, because I don't want to put up something unless I wrote it myself.
Right.
It could be cartoony.
Yeah, it could be. Yeah, a good cartoonist would have a ball with this, I suppose.
Well, we thank you immensely
Yes.
for
Thank
any
you.
questions or your. I'll go home and look at our flood maps.
Yeah. It's called First Street.
First Street Foundation.